In this video, we're going to take a look at binomial expansions, and specifically the binomial theorem. So the binomial theorem is a way of expanding out brackets that look like the a plus b to the 5 that we have over here, but with any given number in the power section. So rather than writing out all the brackets like you would for an expansion like this, so for example with a plus b to the power of 5, that's a plus b times a plus b times a plus b times a plus b times a plus b. And doing out those multiplications can be somewhat tedious, especially as the numbers get bigger when we have higher powers or when we've got higher numbers inside instead of a and b. So what the binomial theorem says that we do is when we have a power like this, so for example x plus y to the power of n, we're going to sum up all of the situations where we have n to the power of or, where or is our position in the sequence, and it's going to be n choose or times x to the n minus or times y to the or. Now that can sound a little bit confusing, so I wouldn't necessarily worry too much about this bit in the middle. But this bit to the right here, where we start off with n choose 0 times x to the n plus n choose 1 times x to the n minus 1 and so on, that's going to be important. We're going to need that. So let's take a look at this example here where we have a plus b to the 5, and we'll actually write out the expansion with this and have a look at how this will work on a calculator. So a plus b to the 5, we're going to start off with, it's going to be 5 choose 0 multiplied by a to the 5, and then we're going to add to that 5 choose 1 times a to the 5 minus 1, so n minus 1, so it's going to be 4 multiplied by b to the 1 plus 5 choose 2, and that's going to be a to the 3 times b to the 2 plus 5 choose 3 by a to the 2 b to the 3 plus 5 choose 4 a times a to the 1 b to the 4, and then at the very end we're going to have 5 choose 5 by b to the 5. So that's how that's going to work with that. And you can notice as we went along each time, the number on top in the brackets here is always going to be the power. The number on the bottom starts at 0, or work this way up to the point where it matches the power. And then we start off with our powers of a are going to match the power that we're starting with, and they descend down by 1. So a to the 5, a to the 4, a to the 3, a to the 2, a to the 1, until we get a to the 0, which we don't even write in. And we got b is working in the opposite direction. So we've got b to the 0, b to the 1, b to the 2, b to the 3, b to the 4, and b to the 5. And then we got to work that out. And this 5 choose 0 and 5 choose 1, that's an explanation for another video. But what we need to do in order to work that out on a calculator, we would press the 5 key, and the shift key, and then the division key. And you can see the little symbol above the division says NCR. So that's what this is used for. And then we would press 1 for 5 choose 1. So it would be 5 shift division 1, and that would be 5 choose 1, and we'd get our coefficient over here. Or for 5 choose 3 to go 5 shift division and 3, and you would get what that's going to be. So if we actually write this out, 5 choose 0 is just 1, so it's 1 times a to the 5, so we just get a to the 5. 5 choose 1 is 5, so it's going to be plus 5 a to the 4 b. Then 5 choose 2 is 10, so we're going to have 10 a to the 3 b to the 2 plus, and then 5 choose 3 is actually the same, it's also going to be 10, so we're going to have 10, and this time it's going to be a squared b cubed plus, and then 5 choose 4 is 5, so we have 5 a b to the 4, and at the very end 5 choose 5 is just 1, so it's going to have b to the 5 at the very end. But this is in the most general terms. It's actually going to make more sense if we start seeing this in a setting where we've got different numbers involved. So let's just try this here. To expand the following fully. So we have this, instead of A we have 2, and instead of B we have 3p, but we're still going to follow the exact same formula that we used up here. It's still going to be this binomial theorem formula up here, and it's still going to look exactly like we've written it out here for the a plus b to the 5, only this time instead of b we've got 3p, and instead of a we have 2. So we're going to start off with 6, choose 0, because it's, remember, power 6, and it's going to be 2, so our a value to the power 6, and then it's going to be times our b value to the power 0, but we don't need to write that in. And then we're going to have 6, choose 1, and this time it's going to be times 2 to the 5, because the powers of 2 are going to, the powers for the a value, for the first value, are going to go down as the powers for the other one go up, so it's going to be times 3p, which is to the 1, and then that's going to be plus 6, choose 2, by 2 to the 4 times 3p squared, plus 6, choose 3, by 2 to the 5, by 3p, sorry, forgive me, that should have been 2 to the 3, times 3p cubed, plus 6, choose 4, by 2 to the 2, times 3p to the 4, plus 6, choose 5, by 2 to the 1, we don't need to write in the 1, times 3p to the 5, and at the very end, 6, choose 6, by 3p to the 6. The 2 has gone down, by the last term, the 2 has gone down to 2 to the power 0, which is just going to be 1, so we don't need to bother writing that in. But now that we've got all that done, now we need to actually work out those numbers. So 6 to the 0 is just 1, and 2 to the power 6 is 64. So we have 64 plus, and then 6 choose 1 is 6, 2 to the power 5 is 32, and 3p is just 3p. And then 6 choose 2 is 15, and that's going to be times 2 to the 4, which is 16, and then 3p squared is going to be 9p squared, like that. And then for the next one, we got 6 choose 3, which is going to be 20, so we got 20 times 2 cubed, which is 8, times 3p all cubed, which is going to be 27p cubed, like that. Then adding onto that, it's going to be 6 choose 4, which is 15, times 2 to the 2, which is 4, times 3p all to the power of 4, which is going to be 81p to the 4. And then we're going to have 6 choose 5, which is going to be 6, times 2, times 3p all to the power of 5, which is going to be 243p to the 5. And then plus 6 choose 6, which is just 1, so I need to write it in, times 3p to the power, all to the power 6, which is going to be 729p to the 6. And then if we tidy that up slightly, we're going to get 64 plus 576p plus 2160 p squared plus 4320 p cubed plus 4860 p to the 4 plus 2916 p to the 5 plus 729 p to the 6. And whilst this process does seem lengthy, it would have been even worse had we tried to multiply that same bracket by itself 6 times over and over again. So that is how the binomial theorem works when we're trying to do binomial expansions. And that's that.